All right, this is the last lesson for you guys if you pass. Just kidding. I hope you guys all pass. Well, last lesson, if you are missing any assignments, let me know. I will email them to you. I will let you know of your grade currently. I'm like always grading all the time. Hopefully you guys aren't spending all of your time doing TikTok videos, all those random thingies. Well, let's go ahead and get started. For vectors, they are portrayed as AI plus B and J. So here, vectors again, it's direction, so it's how you're moving it. It's always array. So here we're going to go ahead and portray it in terms of that. So example 4, we have vector v is equal to 5, comma, -8. All you do to go ahead and convert this is a is your x coordinate, that's what you call it. It'll be 5i, sorry. And then -8 is considered your b, so it's not going to be plus, now it's going to be a negative, so just negative always overpowers a positive sign. So then, that's it. Next one. U and V, they want us to put it in terms of I plus J, but they want us to multiply it. So we're going to multiply our vector U and multiply our vector vector 5. So it's going to be 2 times vector U, which is 3I plus U. Actually, I'm going to leave it in terms of vectors. If I were to convert this in vectors, this would be 3, 2. If I were to convert this in vector, this would be -1, 6. So 2u plus 5i, all I'm doing is doing 2 times vector u, which is 3, 2, plus 5 times vector v, which is -1, 6. Remember what I said? It's like distributive property. When you have parentheses, you're going to multiply 2 to every value between the two brackets. It's going to be 6, comma 4 plus -5, comma 30. Simplifying it even more. 6 plus -5, I get 1. 4 plus 30, I get 34. Again, the answer, they wanted to express it in terms of I plus J. So that means I is your first one. It's just going to be I. You don't have to put one I. You can if you want. It'll be I plus 34J. And that would be your answer for that one. Another way to express it, let's say we can't find our horizontal line and our vertical line. So remember, your graph goes like A, B, and this is your vector or your magnitude. If you don't have your A and B, you can easily find it if you know your magnitude and if you know your argument or the degree. So here it says find A and B and then put it in terms of I plus J. Now let's go ahead and find it. So vector V, if I were to think of a triangle, I'm not going to use that. I'm going to use these two equations up here. You could think of it as using it as a triangle, but that's another method. So we have A is equal to the absolute value V, which is your magnitude, times cosine of theta. Here, let's go ahead and find A. According to A, we use the absolute value of vector V, or that symbol just means the magnitude. So that means the absolute value of 8 times the cosine of the argument, which is radians over 3. Cosine of radians over 3. If you use your chart right here, you don't even have to use your calculator. I wouldn't recommend calculators. If it's in here, I would just use this because it's in fractional form. So cosine of radians over 3 is 1/2, so it's right here. That's considered 60 degrees. So you're going to have 8, the absolute value of 8 is 8. Cosine of radians over 3 is actually 1/2, and A is equal to 4. Let's do B. B is equal to the absolute value, or the vector, times the sine of the argument, which is radians over 3. We go ahead and multiply it up. Our vector is 8, or I'm sorry, our magnitude is 8. Sine over 3, if you want to change this to 8, and then we'll take this 8 out of here. Sine of radians over 3 is considered radical 3 over 2. And then we multiply it and solve it. So I know 2 can go into 8 4 times. B is equal to 4 radical 3. A is 4, B is 4 radical 3. I can write this as 4 comma 4 radical 3. But we want it in terms of I plus J. Your first one is 4i. This one's positive, so it's plus 4 radical 3 J. That's it. Last one, and we're officially done. So here we have find the direction of this vector. So now instead of finding the horizontal and vertical line, we're actually finding the argument. So here it says find the direction of the two. So here, for vector u, I can put it in terms of a vector. I can do negative radical 3. It says plus j, so that means it's going to be a 1. So we're trying to find the argument. Whenever you're looking for the argument, you're using this equation to solve for it. It's what we used when we did polar coordinates to find what that argument is. So the tangent is equal to b divided by a. Remember, b divided by a is your second one divided by your first one. So it's a tangent of 1 divided by negative radical 3. If we think of it as polar coordinates, so let's think of it as negative 3 plus I. So we'll put it in this type of format. We think of a polar coordinate like negative 3, and then positive I is up here. So we have this. This is in vector form, that's why the I is different. But if we were to graph it, so number and then the imaginary number, this will be considered in the second quadrant. So now we're looking for a degree in the second quadrant that equals 1 over negative radical 3. So the second quadrant's up here. So if you were to divide any numbers for here, if you divide the y divided by x, you end up with 5 radians over 3. Meaning the only one that when you divide y divided into x and you end up with 1 over negative radical 3, that would be 100 and 150 degrees. So your argument is right there. All right, guys, see you later. Have a good day.